You're going to be asked to multiply rational expressions, which is rational expressions is a very fancy name for fractions. And then later on, we're also going to divide them. Let's start with the multiplying. And just so you know, with what I give you today, things will already be factored. So you won't need to do the factoring yourself. So it'll show up with the parentheses already there, is what I'm saying. If you are going to be heading into, say, a pre-calculus next year, and a little factoring practice would be good for you, take a look at the advanced version of the practice in this unit, and that'll give you a little bit of a chance to go through your factoring since we haven't done that for a little while. All right, it goes like this. We're going to take advantage of the fact that anytime you have a fraction where it's the same thing on the top and the bottom, that reduces to 1, and multiplying by 1 doesn't change anything, so we're going to cancel those factors away. It can be any factor on the top with any matching factor on the bottom. So let's take a look. Start here with this factor of v minus 4. Do we have a v minus 4 on top? Nope. So this doesn't go anywhere. Now the 7. Do we have a 7 factor on top? Yes, we do. So reduces to a 1, reduces to a 1. 2v plus 1. Do we have another 2v plus 1 on top? Yes, we do. And it does need to be the whole thing. So 2v plus 1 as a unit cancels with 2v plus 1 as a unit. So whole sets of parentheses are what reduce away. And then just take a look at what's left. What's on the top? 1 times 8v, that's just 8v. And on the bottom, 1 times v minus 4, that's just v minus 4. Oh, I was going to make an x. That's just v minus 4. Here is your reduced expression. Don't make it tougher than that. And then as far as restrictions, make sure you check. I'm going to use my highlighter here. How about the blue one? Make sure you check any factor that was ever in a denominator. That includes at the beginning and also at the end. So going back to the start here, when I'm doing my restrictions, I'm going to say, hey, I just want to make sure we don't divide by 0. So v cannot be, from this factor, positive 4. And from this factor, negative 1/2. Don't worry about the 7. The 7 didn't have a variable on it. You can have as many numbers down there as you want. It's only the v's that we have to be careful about. So your final answer has 2 parts. The reduced expression, as I switch over to my yellow highlighter, the reduced expression, and also the list of restrictions. So this whole thing is equal to 8v over v minus 4. As long as v isn't equal to the number 4 or the number negative 1/2. Here's what we got now. Example palooza. So with all of these, quick pause and then unpause when you're ready to check things. On this one, let's see what we can do. Now don't overcomplicate your life. You've been reducing fractions with numbers for years. So 2 and 2, those reduce to 1 and 1. This 2 and this 10 can reduce to 1 and 5. There you go. Now with p's, let's see what we have. I can do this p with this p, and this p to the third with this p to the third. This whole mess is just 5 times 1 over 1 times 1 is just 5. There you go. With one very notable exception. There were p's in this problem to start. And so I need to add a restriction that this p that we used can't be equal to 0. Because if p were equal to 0, I would have division by 0 in these fractions to start with, which isn't going to work out. So all of this is equal to 5 as long as your p-value is not the number 0. Next up, same thing, quick pause, unpause when you're ready to check things. Okay, let's see what we got. b minus 5, there is a b minus 5 on the top. b minus 6, there is a b minus 6 on the top. b plus 7, there is a b plus 7 on the top. So all we're left with is b minus 8 on the top. On the bottom, all of these reduced to little 1s. So it's 1 times 1 times 1 on the bottom. And division by 1 doesn't change anything. So I'm just not going to write anything. So all of this is just equal to b minus 8. With the exception that b cannot be the number 5. B cannot be the number 6, and b cannot be the number negative 7. Because if it were, that means that in the beginning, we would have had division by 0, which is very, very bad. That does not work. So we have to make sure that doesn't happen. So as far as why division by 0 doesn't work, I know you've all heard of a black hole. A black hole is what happens when nature tries to divide by 0. Trust me, you don't want to get close to one of those things. Next up, let's see what we got. Ooh. So as you were working through this one, you may have said to yourself, okay, a minus 8. I see a minus 8. Now this 3 times this a, because they're multiplied, you don't have to think of them as a unit. You can treat the 3 on its own as a factor to reduce with that 6 on its own. So divide by 3 top and bottom. Now this a, you would need another plain a multiplied by something on the top, which we don't have. This a is connected to the 5 of the subtraction. That means these are married. They stay together. You cannot split them apart. So this a down here is going to stay. It's not going anywhere. But you may have wondered, am I allowed to cancel the 5 minus a and the a minus 5? The answer is yes, but they don't reduce to 1 this time. Let's come down here just for a side thought. If I focus on this, 5 minus a over a minus 5, which is what we're doing, this on the top, this on the bottom. We're going to do one round of GCF, greatest common factor factoring. On the top, if I wanted to, I could divide both of these by a -1. 5 divided by -1 is -5. Negative a divided by -1 is a. Now it's maybe a little easier to see, okay, yeah, this and this can reduce away to a 1, but what's left is actually this -1. So can you reduce 5 minus a with a minus 5? Yes, as long as you replace one of them with the number -1. Now, that same thing does not apply to addition. In addition, you can add any order you want. A plus 8 is the same as 8 plus a. That makes no difference. It's only when the subtraction order is different that you've got to remember to put that -1 up in there. Okay, let's see what we got then. On the top, this -1 times that 2. And on the bottom, it's just that a. That's all that's left. We will typically write the negative sign in front of the fraction, and we'll make a note, hey, make sure your a isn't, I'm looking now at my denominators, the number 8. Make sure it isn't, when it's a is by itself, make sure you have the number 0, and from here, the number 5. So a cannot be 8, 0, or 5. Okay, last one. Let's see what we got. This first one, I'm initially going to treat it like this. So if there's no denominator, there really is a denominator. It's a 1. But let's think about what this means. I think I may want to rewrite this whole thing, as a matter of fact. So 10 a to the second times a minus 6 over 1 times a minus 8 over a minus 8 squared. Now, you don't have to write it out this way, but I think it makes it easier to see what's going on. If I take the a minus 8 squared and write it as a minus 8 times a minus 8, I think you can see that, yeah, one of those can reduce with one of those. But that's it. Nothing else reduces. I would need another a minus 8 on the top somewhere, and we don't have one. So my final answer this time is going to be the 10a squared and the a minus 6 on the top. And on the bottom, we've got this factor of a minus 8 still around. Restriction? Well, there's no variable here. From here, we want an 8. From here, we want an 8 again as the restriction, but you don't need to list a restriction more than once. Once you've got it in the list, it's in the list. So to finish it up, here we go. There's our reduced expression. And we just need to make a note that that is good for any a value as long as the number you use for a isn't 8. Because if you tried to use 8, you'd divide by 0, and we don't want any black holes floating around.